Okay, so far we was review some concepts, very to know how to move a robot, and very important concepts as well on that regarding the robot programming. Sorry. Now on this last point, the point number 4, regarding the robot programming, I want to start with the robot program structure and other things, as we will see. About the robot program structure, what I want to show you now, or to read, is what is a robot program, what does it consist on. Robot is able to perform a process with a bit tool, as we were watching before, for example, manipulation, welding, etc., by means of a group of instructions and commands, save it on its memory as code lines. Okay, focus on that word, a group of instructions. Okay, save it in memory, which will be executed one by one to get the robot to perform the movements and other actions, of course, not just movements, because movements doesn't have sense most of the times if you don't combine the movements with other actions, like switching on, switching off, different devices, and different communications. Instructions have to be previously taught by your robot operator. In this way, the robot is able to repeat the process once and again infinitely. Okay, code lines. The code lines can be whether movement instructions, as I told you now, letting the robot move into a specific position previously saved, or whether digital signals, reading, writing instructions. You can set or reset a digital signal, or you can wait for an input, for example, to start the process. For example, trying to move, for example, 2 robots working together on the same space, coordinated without any collision. Okay, so we need these digital inputs, or maybe sometimes analogic signals. And of course, nowadays we are starting to use the most of communications by means of Ethernet connections, by sockets protocol connections. Okay. Okay, and as well, there are another kind of instructions that are control instructions to execute the robot program in one way or in the other, depending on these digital inputs, or these digital inputs or other inputs from the robot itself surroundings. Okay, all of these instructions can be grouped and saved as a robot program. And this is saved in the robot's memory in order to the robot to be able to execute them inside of the control system. Using usually on the control system cabinet, there is a CPU where with a memory inside of this PC, which can be the program is usually saved on this memory. But as well, we have the possibility to take this program as a file, usually as a text file, and take it and download to, for example, a memory USB type, external memory, to handle in our own computer, to modify or just to check something in the robot program while the robot is performing the process. So, and this as well, you can do the operation, just the contrary operation of upload a new robot program or a modified robot program that you did before in your personal computer. However, as we can say here, we can watch here, robot programming is not just composed by code line instructions, but as well what we need is data. this is the instructions without data makes no sense. Okay. This data used inside the program instructions. It could be this data could be position data for a movement instruction to a position. Could be numeric data, just like a counter of number of parts performed during the day. Sorry. Could be coordinate system data, etc. There are a lot of different data that is handled by the robot code program. Okay, so this is the concept of all of the ideas that is inside of a robot program: the instructions, the data, the different kind of instructions, and how can we deal with these instructions through a robot program in a file. Following with that, in a robot program to be more readable and tidy up, okay, the best option is that instructions should be grouped in routines or subprograms to reuse them in different areas. Okay, this robot program is not like a mess of different instructions all together with no structure. Could be, yes, could be, but for us, like human beings, it's not very good because it's more easy to understand if we group all these instructions by means of routines or subprograms, right? And we can reuse them maybe in further operations during the process line. So this is the reason, because we try to group these instructions. For example, it could be we could group instructions regarding the operation of closing or opening a grip fitted onto one robot. All these routines have to have, of course, different names from others, because when we want to execute one routine, we have to call it by its name. So all of the routines defined inside of a program should have.
Oh, that was unexpected. Let me try.
Yo soy el Sorry, online people, we have a fire alarm that are advising that maybe it's occurring or it's not. We have to wait for a minute to if the alarm is going to change into a fixed sound. Now it's blinking, but it's no problem, not now. Esto no estaba preparado. Sí, sí. Joder.
They are checking, but I don't know if it's for real. So
yeah,
maybe
the people who is
sorry.
Online.
Yeah.
The problem.
Maybe we can go out. Yeah. And later we will decide. For the people online, we have like an emergency alarm here. So we must leave the building for a while. So as soon as we reach the turn, okay.
si no se pone fija, solamente para la gente que pertenecemos al grupo de intervención, vayamos hasta allí y veamos qué es lo que pasa. Si después ya vemos que hay un problema, entonces ya se pone fija, entonces no hay que pasar.
Okay. Continue.
Yeah, we can continue.
Okay. It was cancelled, so it's okay.
Okay. Let's go. Yeah. So where we were. Oh yes. I was saying that all the subroutines should have different names to avoid any problems calling to one routine with the next same another one. So this is the way. And of course, there is always a routine from where the robot process is starting and from where other routines can be executed. This routine usually is is called main, the main routine, at least in ABB, but it's not necessarily really to call this routine as with this name, with the name of main. But here on the right of the picture on the right, we can see a robot program structure in different routines. We have a main routine with different with different instructions, one's behind the other one to execute in a sequence. But besides that main routine, we have a circle routine with also inside of this routine, we have different instructions as well. And I put this as an example, of course, and we have a square routine as well with different instructions as well. This circle routine and square routine could be called from the main routine in different positions. As we can see here, there is instruction to execute the circle routine, and for example here there is the other instruction to execute the square routine. In that way, the robot could be able to perform a process to draw, for example, a square or a circle on a table. And this is the way of the structure program. Not all the instructions together in a messy way, but a structure in different routines inside of the program. So, what else about this? Okay, now we are going to watch how to manage a program execution. Okay, how do we execute a program in any kind of robot, depending on the brand of the robot, or if it's one brand or the other? We have to try to switch on one dedicated window called the programming window. From this window, we will be able to select a robot program, the robot program saved on its memory, of course, previously for someone, with the robot movements as well saved on it. Okay, from this programming window, we could select this robot subroutine, and as well we could start to execute to check if that routine is correct or is not, and we could modify or not, or just to put the robot to work in an automated mode. Okay, so to do that, there is also on this window, there is an indicator in the programming window to point out and highlight the next instruction is going to be executed by the robot when we push the play start button. This indicator is named program pointer. It's shown on this window on the teach unit in different ways depending on the robot's brand. but it should be always there existing this kind of window. To execute the robot program, we have to place, of course, this program pointer as this program pointer onto the first instruction of the routine we want to execute. And afterwards, once the program pointer is on this first instruction, we can press the play button on the teach unit to perform and execute that program. Or just push, if we push the play button, the robot is going to execute the whole instructions inside of the routine. But if we want to execute just one instruction by one instruction, step by step, we have to push the step forward button instead of that. We can move the program pointer inside the selected routine to other instructions instead of the first. Okay, of course, we are not. It's not mandatory to put the program pointer on the first instruction of the routine we want to execute, but we can put in another instruction. We can jump several instructions without executing all of them, doing this in this way, using for that the step forward button as well to start to execute just instruction by instruction once we have already jumped the instructions we don't want to execute. Okay, and finally, something that we can also modify when we execute a robot program, attending to regarding the instructions or the movement instructions of the robot, we can change the speed or override field or parameter in order to get to modify the speed or the execution speed of the robot when it is executing a movement instruction. So we can modify the overall behavior of the robot when it executes a robot program. Okay, so we can select the 100% of the programming speed, or we can select till the 0% the programming speed. In that way, the robot, when achieve one instruction movement, the robot is going to stop, of course, because can't not move because it's at 0% of the speed. So this is some of the concepts regarding this programming window we have to take into account when we are starting to program a robot, or when we are going to start to execute a previously programmed program. Next. Okay, now in this slide, I want to show you the first and the most important two instruction movements of a robot. These are focused on ATD robot brand. It could be Kuka, could be Fanuc or Motoman, but I decided to use this because it's the robot that we have downstairs. So what we can watch here is that with this kind of instruction, the robot is able to move from the current robot position to the position previously taught inside of this instruction. So when the robot wants to execute one instruction of this, move L or move J, the robot is going to move from the point the robot is in that moment to the point that is saved on this kind of instructions. Okay, and depending on the instruction, the robot can move in one way or in the other. We see now further. So, as I told you before, the ABB robot movement instruction is composed by the next fields or parameters inside of an instruction. Okay, move G or move L is the name of the instruction, and it's depending on the name, it's the robot is going to perform a kind of movement. It could be a move G or a move L, and depending on this, the robot could move in such a way or trying to execute a linear movement. We will see what's the meaning of move G. Move G is the easiest way for the robot to moving from one point to another in the space without performing a linear movement. It's like he decides which are the axes that have to move to reach one position, but without describing a line in a linear movement. This is easiest for it because the Axis computer is not so overload with the different mathematical calculations that have to perform to get a perfect linear movement along the space, right? So really the move G instruction is the easiest way for the robot to move from one point to another one, but is the way that we really don't have any control on this. If we are going to speak, if we speak about regarding the movements about processing something on a part, we have totally control of movement of the robot when we execute a move L movement. So the move G is just to move the robot from one point to another before starting to work on the part. Okay, but when we start to work on the part, we need to work always with move L instructions. All right, so these are ABB movement instructions. The first is the name always. And afterwards, we can follow the different parameters. For example, for this moving instruction, we have the next parameter. The first one is which point we want to move the robot. In that case, this is a data position with the name of P10 or P home. We could give a position data saved with the name we want, okay? And inside of this data, of course, what we are going to have, the coordinates of the position that the tool fitted to the robot has to achieve, has to reach. In that way, is X, Y, and Z. And rotations in X and Y and Z as well, axis of the tool. And of course, if the robot has external axis, this information is also inside of this position data. More parameters on these movement instructions. Of course, something that the robot have to know, besides the position that it has to reach, is which velocity or which speed we want to move the robot. This is the speed data. In this case, it's in millimeters per second. In KUKA, is in meters per second, as I remember. Here is the name of this speed data. One is V100 and the other one is V1500. Inside of this data is a couple of numbers describing how is the velocity and the acceleration of the robot to reach one position. Okay, next parameter is the precision data. This arrow is not pointing correctly, but this is the position data. The data with the name of fine or with the name of Z20. This data is the precision we want the robot reach one point in the space during robot trajectory movement, right? So, of course, if we think that we are going to work with robot, we want to perform the process with the highest accuracy as possible, of course. But sometimes we don't need that the robot performs a very accurate trajectory because we want more fluently movements along the trajectory. So if we, for example, let me explain you. If we are going to use in all of if we have a sequence of instructions of moving a robot for describing a trajectory in the space, for example, going, let me show you with a share for the people who is online as well. It's better, maybe it's better to understand. If I want the robot to perform, for example, a trajectory from this point, passing through this point, and this point, and a square, for example, I could program these movement instructions with, I could program these movement instructions with precision data in fine. In that way, the robot movement is going to be in that way. The robot start, for example, from one point in the space, far from the part, and they start moving in that way, to this point, to this point, to this point, to this point, very accurately, okay, but stopping just for milliseconds in one point, in each point of the trajectory. When we are, for example, having an arc welding process, we can't perform this trajectory when with the robot stopping for milliseconds in each point of the trajectory, because if not, the welding material is going to be growing, and it's the welding seam is not to be constant. So to avoid that, what we are going to do is telling to the robot that on each point of the trajectory, of the arc welding trajectory, we want it don't stop more. It doesn't stop and perform maybe and cut the trajectory like in this way. I can show you this concept on the right picture on this slide. When we use a precision data different from fine, for example, the precision data of Z20, the robot behavior is going from this point to this and to the other one in that way, following the straight line that you can see here. If we use, instead of Z20, the fine precision data, the robot will perform this other trajectory, the dotted trajectory on here with a stopping position here for, during milliseconds. All right, and this is not good for some processes. To avoid that, this is the reason we use different accuracies for precision data. I don't know if I could explain it correctly or not. Maybe it was not very the best. But,
I have one question. What does 20 mean?
All right. Thank you, Java. When we don't want to use the most accurate precision data, we could use others. And these others, what we can program inside of this other precision data is a radius of the precision zone that we want the robot perform. For example, if I put Z20 instead of fine, the robot is going to start from moving from this starting point to this, But when the robot collides with an imaginary sphere on the space of radius 20 millimeters, the robot is going to start to move to the next instruction, to the next point. If the precision data is not set 20, is, for example, set 100, the robot will start to move not in that point, but at 100 millimeters from the program position. So this is the concept. All right? Yeah, really? Over there. So this is another parameter that we have to put inside of the movement instruction. Okay, the precision data. The other one is the tool data. Of course, we have to say to the robot which of the tools we want to work with. So, because the robot finally could have different tools fitted to the robot flange. Downstairs, there is only just one gripper, for example, attached to the robot flange, but could be have two of them or three, or maybe with an automatic tool changer, we could have more different tools for the robot to work with them. So inside of the instruction movement, it's mandatory to say which tool we are going to work with. This is the tool data. And finally, of course, what we need as well is when we say the robot, okay, go from this point to the other one with these coordinates X, Y, and Z. What we need to know is which is the reference. What the robot have to take. So this is the base data parameter that is inside of the movement instruction. In that case, we have here world at 0. This is the robot base reference system, and could have others like, for example, this one, world at fixture 1, for example, that was previously defined by the robot operator, for example, in the robotic cell everywhere, maybe in a fixture. Okay? So this is the presentation of the most important instruction of to move a robot. And nothing else about these instructions. Of course, this is for ABB. For other robot, more or less, maybe the name is not the same, but are similar. Maybe they don't use these parameters in that order, but in other. So, but the concept is always the same. Okay, this is data that is mandatory. The parameters that are mandatory to use inside of an instruction, movement instruction, right? And what else? To finish, I want to show you here a robot program sample with three different routines. The first one routine is the routine with the name of main, as we can see here. And inside of this main routine, we can see different instructions that will be executed in sequence when we want it. These instructions at the beginning doesn't exist inside of the main. We have to include inside of it when we are teaching the robot what to do. Of course, what we have here are, besides the movement instructions like this one or this one here, we have other instructions, as I told you before. These are instructions to control the digital inputs and outputs, about resets, wait the digital input here, wait the E, so on. And on the right, we have two routines more. One of them is describing and drawing, for example, a triangle in the space. To do that, as you can see, we use always move L instead of move G to work on the part. And there is another one routine that is someone to draw a square with a robot, for example. It's an example I did some days ago to show you what's how is a robot program as an example. So this is something that we are going downstairs try to perform in the next practice. So far, if you have any question now, you can ask. Maybe the people online as well, because now we are going downstairs for the second practice.
Let's start. Yeah. Okay. So go ahead. Now I'm going to open the programming window. Is the way to access to the memory of the robot regarding the robot managing, programming, etc., and executing as well. We can select, okay, depending on the robot's brand, the different windows, we could access the different windows from different ways, of course. From the ABB teach unit, we have here to select the main menu to select different windows, of course. I like to open always the movement window. And besides that, I have to open the program editor window. Here we can see the structure of the program that is inside of the robot, because here now the robot is working with different programs that we are going to show you next date for tomorrow for the next session, but for other trials and projects that we are working with here. So there are a lot of codes here inside of the robot, not just the one that we are going to do. Let me select our structure of the program to avoid any problem with the other codes. I made like a framework to work inside of it. I call it Isidro training course. Inside of this Isidro training course, I created 3 routines. They are empty with no instructions inside of that, with no data inside of them. One routine is like the routines like we saw before upstairs. Okay, the name of one is the main course. There are another one with the name of square and the name of triangle. So now the sequence is to start to teach the robot some trajectory movements to execute them. So here, what we have here is not a tool to perform a correct drawing of a circle or of something like that in the space. We have a gripper, but we are going to imagine that there is something, and the robot is going to, when we will start to execute the program, we will see how the robot move, describing a triangle in the space or a square or something like that, but with the gripper, right? Because it's the only gripper, the only tool that we have fitted on it. So now these are empty. These are how the routines, the 3 routines are empty on the memories of the robot. All right. So they are free. Have yeah. Is every brand of robot has their own language to program, but the philosophy finally is always the same. You have to adapt to the instruction set that the robot manufacturer brand gives you. For example, ABB have the advantage that they offer you a very large set of instructions. Very nice. But with that instructions, you can do the same with a KUKA robot. But with an instruction set more reduced, you have to work more on the robot program to do the same. But finally, you can do the same with another brand. With this, maybe it's easy, but okay. For me, for example, like a programmer, I prefer robot programming because it's more clear. You with a simple view, it's more clear how the robot is going to execute a program without doing it. Okay, it's more intuitive from my point of view. But maybe other people prefer some KUKA or Motoman or something like that. Yaskawa. So what I'm going to do is starting to program a first instruction inside of the main routine. For example, I want to save a home position. A home position usually is the position from where the robot starts to execute a process. So I'm going to create that instruction. Usually, as this is the first instruction, I'm going to create a move G instruction movement, not a move L. Okay, move G has more advantages sometimes when you are not working on the part, as I told you before, but outside of the part have several advantages better than the move L. That is a little bit more limited. Okay, we have to know why and why not, but maybe in another training course more in deep. For doing that, what I'm going to do is to add the set of instructions that ABB offered me. Okay, I can open, open here this palette of instructions. They are grouped as well in different areas depending on what we wanted to use. So now we are in the most common instructions. We can see here the move L, for example, and move G, right? Move L, move G, set, reset, if, etc. So now pushing down some of this instruction, it will be added to the routine that we have selected is the main. And I'm going to push on the move G, as I told you before. And it's now is on the routine as a first instruction. Okay. This is the first instruction. The name of this instruction is a dotted point, or I don't know the name in English, sorry. The start point or something like that. Now I'm going to put a name to this data position. Let me do it. Okay, editar. All right. Editar. Yeah, okay. It was here. No, it was not here. I'm going to create a new point with the name of P home. Okay. What I have here is an instruction with a data position with the name of P home. and speed, the accuracy we want the robot achieve, okay, and so on. And this is what I have. Now I'm going to save a good position for the home position. I'm start to move the robot with the joystick, okay. I'm going to put the robot in that with that orientation. And for example, let me go up, maybe. This is, for example, a good home position outside of the part. What I have to do now is to push save that position on the point P home, okay, and that's all. Okay, modify position, modify. Now this position with the coordinates are saved on the robot's memory program. So we can proceed with the next movement instructions. Now, if we want to perform a square, for example, we have to go to the square routine to start introducing the different move L instructions to perform this square. To do that, I have to select the square routine and start to add the instructions like before. This is the square routine is empty with no instructions, and I have to select now move L instruction, right? This is all right. Let's go. So I have to push move L, and it adds me the new instruction. I have to put the name of the position data. In that case, I'm going to put a point with the name of square 10. Okay. Let me, I'm changing as well the other parameters, the speed, the precision. Okay. Now I have a square routine with the first instruction of moving L. Okay, the square routine with the move L instruction. All right. And now I'm going to add the 3 more. Okay, no, I have to save the first point of the square. To do that, for example, I move the robot, for example, to the first square position, maybe here in that point, and I push save. Modificar is saved. Now I can move the robot. Let me. I'm going to change the position because the richness of this robot is not very wide, so I prefer to start from this point as P10. Again, I'm going to modify again the previous modified position. Okay, this is the first point. This is going to be the second one. To do that, I have to add another move L instruction below with the name of 20, square 20. Okay. I have to push here, modify position to save the position. Yeah. No, this is the speed. The speed of V100 is 100 millimeters per second. Okay, the override is here. It's on that way. We have to modify the override on the speedometer here, modifying. Now, if we execute, it's going to execute in 100% of the of the robot instruction movement. But like it's in manual, is going to perform in manual, it's always limited. In manual mode, the robot is always performing the programming, robot programming, limited by a value, usually below 200 speed, 200 millimeters per second. So this is the second point of the square. I have to save it. Okay, modify. Now I move the robot to another point. For example, this point. This is a good point. I add again the third move L position instruction with the name of square 30. All right. And now the next one, the point of the square on here, more or less. Maybe it's not a perfect square, but you understand, okay? I add the instruction. I will show you now. Okay. This is the program with the 4 instructions. Do you think is enough, or we can try to execute it and check how is the behavior of the robot? Yeah, the people who have experience on that is detecting that is something wrong in this program. We are going to check, right? For the people who is at home, this is the robot program with 4 positions to draw a square in the space. There are some people that is telling that is something wrong, that is going not to work properly. Let's see. To execute this program, this square, okay, it's something more. We need one more instruction. We need to call the square routine from the main routine. Okay, we need one instruction in the main routine. To do that, we go again to the main routine, and we have to put, besides the move G from the P home, we have to add an instruction, a control instruction that calls the square routine. To do that, I add another instruction that is proceeding call, routine call, and too many. All right, okay, is the first one. All right. So this is the main with the movement of move G, with the calling to the cuadrado square routine that is below. All right. So I'm going to execute this. So let's go. Okay. First, I'm going to execute the first movement, move G P home, and the robots move from the point is it to the programmed position, right? Now, if I push the play button to execute the complete sequence of the main routine, calling to the square routine, etc., the robot is going to perform the complete sequence just one cycle. Let's see. I'm going to push play. Sorry. Here, the hardware button on here. And let's go what happens. This is the first point, the P10, P20, P30, and the robot is moving in a linear movement because we use it. Sorry, I forget. saving the last position. Let me go to the point 30. This could be the point 40. Save. And again. Let's start again, please. Okay, again from the home position to the P20, P10, P20, P30, P40. Now P40, and it should go and close the square, but it doesn't. So what we have to do is copy and paste the first instruction to close completely the square. So let's do that. Cuadrado, copy the first instruction, edit, copy, and paste. Now this is how is the final instruction. Okay, to perform completely close the square, right? So we can proceed again. And I'm going to add another position again, that is from the point 10 going again to the backwards to the home position. So I have to add an instruction inside of the main routine. Copy and paste as well. So let's go. He starts again from the home position. Now he goes to the P10. Now P10, P20, more or less, okay, P30. But please pay attention. The robot is moving in that way because I put in the instructions with the high accuracy should be. And as you can see, it's a movement of a very mechanical, okay? It's with a little stop in the middle. I'm going to change it to you understand the concept of about the precision data I explained it to you before. Mostrar rutina. Okay. Okay. As you see here, this is the accuracy is fine. So it's the highest accuracy. Is fine. Is fine. I'm going to change by another data precision. Maybe set 100 is enough. 100 millimeters to check that it works correctly. To do that, sorry, it's not here. Okay. Okay, I put this precision zone just in the points in the middle of the square, not in the P10, because I want to start the process just from the P10, but not for the others. So the robot is going to be a rounded square in the corners. So let's go. Okay, home position now stops for milliseconds in P10, and now just pay attention that is going to round. Okay, it did. Right? Now again, it's like a rounded square in the corners. Again, and it's more fluently, okay? It's more fluent, the movement is more, in this way, the robot doesn't suffer so much because decelerations are not so high. So it's better to the robot and maybe for the process. It depends, of course, on the process we have to perform. No, it's just it cuts the trajectory in circles. Okay, for the people who is at home, let me show you what I changed. It is that, which is in blue highlighted. Instead of fine, I put Z100. And I don't know what else to show you. I think, do we have more time for the triangle routing, or we could stop maybe? Oh, so do we have to stop and to go upstairs for the next? We have time. Okay. Any of you want to program a triangle just in the space in different points to add instructions? Any of you? I can stay with you. Yeah. All right. So first of all, we have to select the correct routine. So there are here, select the different routines we have, and we are going to go to the triangle to add the instructions. Oh, sorry, it's in Spanish. Mostrar rutina. Okay, now it's empty. We have to add instructions, movement instructions, just this. This is add instructions, edit, and in English, play. So add instruction. No, don't worry. This is here. This is like Windows. You have two windows open. So we are going to add a move L instruction. All right. What we have now is with no data position inside, but we are going to change. To do that, we can push on the start point or on the name of the instruction as you want. Now he understands that you push it here, yeah. And now let's go some predefined I did yesterday just to, this is triangle, P10. Okay. And you have already added, okay, okay again. Yeah, you have already added an instruction. If we close here, you can see your instruction with this speed. We are going to, now I want you to change the speed and the precision zone, please. On the, okay, on the name, again, twice. Speed 100, V100, yeah, just for safety reasons, but of course there is a limit of no more than 200. And the fine is the above. More, fine, perfect. Okay, and it's finished. Yeah, it's finished. We have added one instruction to the triangle routine. Any of you want to add any other instruction? The second, no, we have to save. Sorry, we have to save. Okay, to save is here, to modify position. Move the robot in linear to 1 point over more down. I don't know. Here, maybe. Come. It's not necessary, but it's not necessary, really. You have to push the safety measure. It's in reorientation. Put in linear. Yeah, this is. Down. More. Here. Okay. Yeah, a little bit forward to you. Over there. And now save the position when with the instruction selected, you can modify position there. Confirm, modify. Perfect. It's saved. Nice, easy. Raul, if you want to try, again, try to move. No, we are going to add the movement, the instruction. Yeah. Move L, yes, please. Below. Now we have to change because it automatically put the name they want, but I have the predefined data. So try to change for the P20 triangle is over there. Yeah, that's better for me. Maybe we can change as well. No, it's okay. It's V100. I'm fine. So go ahead. Okay. And now we have to move the robot from this point to another second point. More, the robot here hasn't too much reach, so maybe go to there. Dale, dale, go, go. Okay, ahí. Spanish. Save, modify position. All right. Any other who wants to? Yes, but I prefer to do with other. Yeah, this is for the next day. Don't worry. Any of you? Yes. If not, I do. Sorry. So yes, try to add below this is highlighted the last instruction, not the last, but almost. Move L. Now we have to change. No, it's okay. Select the triangle again. Again, the okay. Push again. Is over the name of the instruction. Is easier. And change for triangle 30. Is over there. Yeah. Okay. Now it's okay, perfect. We have to move now the robot to, for example, to a position over here and save. Go, go, go more. Yeah. Okay. Now we can save, confirm, and modify. Confirm, and that's all. We have to add now to close the triangle. We now to copy and paste the first instruction. So yeah, with strength. Editar, copy. Por debajo. A ver, let me check. All right, perfect. So we can start. Okay, what we have to modify is the main routine from where we call the triangle routine. So we go now to the main course. After drawing the square, we can call the triangle routine. Now we can start to execute. Any of you want to execute the program? It's nothing, just to push the safety and push the play. If there is something that is wrong, you hold off the safety and no problem. Or push the stop button if instead of, as you want. Yeah, when you have to push, okay, its motor is on. Now you can play, and the robot goes to home position. Now start to draw the square with the rounded square, with the rounded corners, and afterwards goes again to the home position and start to draw the triangle, and that's all. These are the square rounded corners. Home position, and now the triangle, the first point, and this is with the high accuracy, so the robot is going to perform the movements with very tiny stoppings. stops now when it arrives to the, I think. Yeah, you need to press. It's a safety measure, so it's always pressing. If you want the robot to move, you have to press. If no, because it's a safety. Just you think that maybe you are working with the robot moving, because of any of reason the robot hit you, and you are remaining below the robot. So the only way that the robot doesn't continue moving and hurting you more is releasing the safety measure to avoid that. Okay, all of the robot brands have their own safety measure. A 3-position switch. We will speak about these safety measures next sessions tomorrow. So, yeah. Yeah, if the signals between the tool and the robot are correctly integrated, maybe by means of digital inputs or outputs, or maybe by means of Ethernet protocol, for example, you can handle this communication, and the robot could proceed with opening and closing a gripper, for example, or something like that. Yeah. Yeah, and you call these subroutines to perform that. I don't know. Yeah, whatever. Yeah, really. So on my side, this is all.